everyone, and welcome to our interview. Today we're talking about a big and controversial topic, designer babies. To help us understand the science behind it, I'm here with Regina, who's our genetics expert. Thanks for joining me.
Thanks for inviting me. I'm excited to explain how all of this works.
What is the mechanism that makes cutting and pasting DNA possible? How does it differ from older gene therapy methods?
Great question, Karimi. So, the main tool that we use today is called CRISPR-Cas9, and it works in two parts. First, guide RNA, which finds the exact spot in the DNA that needs to be edited, and Cas9 enzyme, which acts like tiny scissors that cut the DNA at the exact point. Now, once the DNA is cut, scientists can remove a mutation, repair it, or insert new genetic material, and that is what allows the cut and paste process. Compared to older gene therapy, CRISPR is much more precise. Older methods usually added new DNA randomly into the cell, which didn't fix the original mutation. This new process directly edits the existing DNA, making it more accurate and powerful.
What is the difference between therapy and enhancement in this context? Have any designer babies been created? And if so, what were the consequences?
Therapy means correcting a genetic problem to treat or prevent a disease. Enhancement, on the other hand, means choosing traits like intelligence, strength, or appearance, things that go beyond treating illnesses. As for designer babies, there was one major case. In 2018, scientist Heiji Anuki edited embryos to try to make them resistant to HIV. The babies were born, but the experiment violated ethical rules and the safety results are still unclear. It showed that while germline editing is technically possible, it is not ready for sale or responsible use. Most gene editing done today is somatic ending, meaning it happens in a person who already exists and the changes are not passed down. Germline editing embryos so future generations inherit the change, is mostly banned because of the risks.
How could germline editing eradicate genetic diseases? What medical benefits will be realized without enhancement?
So, germline editing could eliminate certain genetic diseases permanently because the corrected genes would be passed down to future generations. Some examples are cystic fibrosis, Huntington's disease, sickle cell anemia. And we also have pre-implantation genetic diagnosis, which is abbreviated as PGD, and it is used during IVF to check embryos for genetic disorders. So this PGD is already helping families avoiding passing severe diseases to their children. CRISPR could in the future allow us to fix a harmful gene instead of just selecting the embryos. The medical benefits are huge, as long as the focus stays on therapy and not enhancement.
Okay, so who decides which traits are desirable? How could this technology increase social inequality? What are the unforeseen biological consequences of editing the germline?
These are some of the biggest concerns with designer babies. So first, who decides what is desirable? If enhancement becomes allowed, someone would have to choose what traits are better. This can be influenced by bias, discrimination, and cultural pressure. Second, inequality. If gene editing is expensive, only wealthy families could afford it. That could create a society where rich literally have biological advantages over everybody else. And the third one is unforeseen biological consequences. So, since we don't fully understand all the long-term effects of editing embryos, a small mistake could create new mutations that get passed down through future generations. These risks make scientists and ethics argue for strong limits or germline editing.
What is the biological difference between gene editing and cloning? Why is cloning relevant to the designer baby discussion?
So, cloning and gene editing often get mixed up, but they're completely different. First, cloning creates a genetic copy of an entire organism, just like Dolly the sheep. And gene editing changes specific parts of the DNA inside an existing organism or embryo. Cloning is brought up in the designer baby debate because both involve controlling human biology. But cloning is about copying, while CRISPR is about modifying. They raise different ethical questions but are sometimes discussed together.
Thanks for explaining everything. Before we finish, what's your overall stance after looking at both at the science and at the ethics?
I believe that gene editing for medical therapy has amazing potential and could save many lives. However, using it for enhancement is risky and could create huge ethical problems. Right now, we should focus on safe medical uses and avoiding crossing into areas that could harm society.
I agree. The technology is powerful, but we need strong rules and responsibility. Thank you, Regina, and thank you all for watching. Check our reference page for our sources.
See you next time! In 2018,
Have any designer babies been created, and if so, what were the consequences? Have any designer babies been created, and if so, were the consequences?
We're rich, literally have